I'm going to give you a heads up. Solving exponential equations, there's also a very specific way that we do it and we show our work, and you're not allowed to do it a different way, and there's good reasons for that. So that's part of what you're coming to terms with today and tomorrow when we do this, is how you show your work, what's the right way to do it, what's the wrong way. We'll do a learning goal at the beginning of class tomorrow, and if anybody's got the wrong form, I'll tell you, and you got to fix it for the test, or you're not going to get marks for those questions. Okay? Okay, so let's think about this. If I wrote this question, okay, this is an exponential equation. Why is it an equation? Because the equal sign, you notice, is different from what we've been doing over the last several days, because the equal sign is between the left side and the right side. So that makes it an equation. Equation is something that's balanced. This equals this, and we're finding out what x makes it true. And you would have seen in grade 10, sometimes it's more than one x. Sometimes there's lots of x's, but so far in this course, we've only ever had one x. So there's a left side and a right side, and the equals is in the middle. That's what makes it an equation. What makes it an exponential equation? Exponential equations have the x, or the variable, in the exponent. That's what makes it an exponential equation. We solved equations with brackets, equations with fractions. When we were doing the preview warm-up for the course, this is a different kind of equation, an exponential equation. And as I said at the beginning, we solve these a very specific way. Okay? Does anybody know what the answer to this is? What x makes this true? Why? Yeah, 2 squared is 4. So by inspection, we can see that this is 4. You don't have to write this down, but you could if you want. The x is 2. By inspection, and this is how people like to solve the easy ones, but you can't do the hard ones this way. This is why we need a better system. By inspection, you can see that x equals 2, because 2 squared is 4. Okay? But like I say, that's not good enough. So if I write it like this, 2 to the x equals 2 to the 2. This is important. And I want you to write this down. If the bases on both sides are the same, the base on the left side is 2, and the base on the right side is 2, then the exponents must be the same. Right? Doesn't that make sense? Put your pencil down and watch. Don't write this down. Just watch for a minute. I'm just going to scribble here in the space, empty space. Leave the rest of it up. Like if I wrote 2 to the 2 equals 2 to the 3. Does anybody believe that's true? The bases are the same. The exponents are not the same. What is the only thing that I could write there that would make the left side equal the right side? The only thing I could write is 2. If the bases are the same, the exponents must also be the same. Okay? Okay, now you can write this down just below. Be careful, because it's not uh, 2 to the x equals 3 to the 2. because the bases aren't the same, so the exponents are not the same. 2 to what exponent equals 3 squared equals 9? Well, not a nice one, a nasty one. We're not worried about that, right? So that's not what we're doing here. The bases are different. In fact, we don't know how to solve that. You need a whole different kind of operation to solve that, okay? Not this as well. 2 to the x plus 2 to the 1 equals 2 to the 4. Some people might think, oh, it's 3. No. This is also doesn't work, and it's not true because I've got 2 bases on the left, and again, in that case, we can't do it. Okay? Not that it's not possible. It's certainly doable, but those are not the kinds of questions we're looking at. Okay? So, in general, what we're looking at, in general, if I have 2 to the a equals 2 to the b, what can I say is true? A lot of people don't like it when we do these general things with variables in them and stuff. But what would be true here? Mackenzie, what do you think? Very nice. A equals b. Or even better, I could do like if x to the a equals x to the b, because the base can be anything. It doesn't have to be 2, that's for sure. Therefore, then it must be true that a equals b. That's the only way to make it true. Make sure you understand that. You convince yourself that that's true. So if I go back up here, how do I complete this question? I go therefore, notice that I'm using this therefore sign every time. I'm going to talk about that in a minute. X equals 2. Okay, I'm going to do another example. What if I did something like this? 2 to the x equals 8. What's the answer? 3. But we don't want to just, this is what people are going to write. It's wrong. Don't write this down. This is the wrong way of writing it. 2 to the 3 equals 8. X equals 3. I know you think that's fine. It's not. So this is how we're going to write it. We're going to go 2 to the x equals 2 to the something. Okay, and I'm going to make myself a little note here in my note. Rewrite with base 2. Why did I pick 2? Because the left side has a base of 2. If the left side had a different base, I'd choose that. I have to rewrite 8 with a base of 2. If I didn't know it was 3, I'd have to just guess and check. So I put a 3 in there. And then the next step is, therefore, x equals 3. And I'm going to tell you why we say therefore. If you don't agree or don't like it, that doesn't matter. You got to do it anyway. We say therefore because we didn't do an operation to go from that step to that step. We're just using this idea that if the bases are true, the exponents must be true. And in mathematics, when you don't do an operation, you're just drawing a conclusion, we say therefore. So at this step, when it changes, it's not always therefore x is the answer. That's not where it is. You'll see when we do more examples. When I go from an exponent and the exponent's gone, that's where I use therefore. Every time you solve an exponential equation, you're going to have a therefore in there somewhere. Everybody okay with this? Okay, let's try a couple. Example 1, solve each of the following. How many people already know what the answer is? Or have a guess? It's not 2. It's not 3. We already saw those. What's 2 to the 4? What's 2 to the 5? What's 2 to the 6? What's 2 to the 7? That's what you're asking yourself. But we're not just going to write x equals the answer because we're practicing for the harder ones. We're going to do this. So 2 to the x equals 2 to the something, and we have to figure out what that is. We need it to be both left and right sides in a base of 2. So what is it, Tanner? What is it? 5. You don't have to write the little box, by the way. I'm just doing that because it sort of helps us realize what we're doing. Check on your calculator. 2 to the 5 is 32, if you want. It is. Therefore, x equals 5. Boring, because those are, you can solve by inspection. Let's try a harder one. Is everybody okay to move on to B? Everybody got that down? B is where it starts to get interesting. B is where, like, oh, I don't know what x is. And this is just the tip of the iceberg. These questions aren't that hard. A lot of people will have a lot of success with this. It seems strange at first, I know, but they're actually pretty good. What's the base on the left side? Bethany, what's the base on the left side? What do you think? Two. Very good. Right? You gotta identify what your base is. So if the base on my left side is 2 to some exponent, which in this case is 3x plus 4, I have to do this one base 2, same base, to something. Didn't we already do what that something is? What is it? 5 again, because it's still 32. And watch what I do now. I go, therefore, 3x plus 4 equals 5. If the bases are the same, the exponents must be the same. See what happened there? So I can't just solve this one as easily because it's got a lot more junk going on. And now how do we solve 3x plus 4 equals 5? Oh, was that a hand up? No?
I just had a question.
Sure.
So we never worry about the variable. Never worry about the exponents. If we're just trying to find the x, it'll always be whatever's comes like.
I think what you're asking is the first. Well, we're going to work on them now. The first step, you're right, has nothing to do with the exponent. We're just looking at the base, which in this case was 2. In every case so far it's been 2. It's going to change in a minute, right? We're just looking at the base. But now look at what I have. I have just the exponents. So how do I solve this? I go minus 4, and I get 3x equals 5 minus 4 is 1. And then I divide by 3 and divide by 3. And I get x equals 1 over 3, 1/3. Leave it as a fraction. We don't need decimal answers. No, our therefore was there. You're not going to lose marks if you write it, but don't write therefore in every step hoping that one of them's right. This is the therefore statement when I go from having an exponent with a base to not having it. Okay, let's try another one. More interesting again because it's got a different base, although it's already done for us. What must be true if 3 to the 5x minus 2 equals 3 to the 3?
5x minus 2 equals 3.
Yeah, the bases are already the same, so therefore 5x minus 2 equals 3, and that's like this 3. Add 2 to both sides. Divide both sides by 5.
Do we have to show all the steps like dividing by 5?
You don't have to show the red parts. No. That's what you mean, right? Yeah.
So our therefore statement will always be when they equal each other.
Right. When the exponents equal each other. Here's another one. The left and right side are already in the same base. 3 to the something equals 3 to the something. Remember what we said before. If the bases are the same, the exponents have to be the same. Whatever the exponent is, it doesn't matter. It can be a big pile of junk like this. It's still equal. So this is where we go, therefore, the exponents are the same. 5x minus 1 equals 3x plus 2. And this is our quick little reminder of how we solve these kinds of questions. So I'm going to move the negative 1 to the other side by adding 1 to both sides. And I'm going to move the 3x to the other side by subtracting 3x. Now you see why we were doing this the other week. 5x minus 3x is 2x. 2 plus 1 is 3. This is gone and this is gone, right? Divide both sides by 2 and I get x equals 3 over 2. Any questions? Okay, let's keep trucking. Here's our next example. E. What do we have to do as a first step? Like, what if I wrote this? Okay, after you got it copied down, put your pencil down and watch. What if I wrote this? Don't write it down. Therefore, x minus 1 equals x. That's what we did in the other examples. Is this right? What do you think?
No, because the base isn't the same.
Very good. The bases aren't the same. I got a 2 on one side and a 4 on another side. So whenever this happens, you have to rewrite with the same exponent. What can I change them to? Kenzie? Nice. So 2 to the x minus 1 equals something to the x, and 4 is 2 to the 2. Two to the x minus 1 equals, what is 2 to the 2 all to the x? The bases are the same, but this has brackets and stuff going on here, so I don't think we're quite ready yet. What's my rule when I do a power of a power? Sarah? You multiply. So what is 2 times x? 2x. Now I have both sides written with the same base, and I go, therefore, x minus 1 equals 2x. And in this case, I'm going to subtract x from both sides because it's going to be the quickest way to solve. So it's gone on this side, and I get negative 1 equals 2x minus x is just x, which is the same as x equals negative 1. So in this case, as we said before, but we must rewrite to the same base. And most of the questions are going to be like that. These are the ones that we're interested in. So we were doing those simpler ones before to see what was happening and work our way up, but these are the ones that we're more interested in. Everybody good? Just going to show, we got 4 more examples, and they're all slightly different types. I've got a base of 3, and I've got a base of 27. How can I rewrite them to be the same? Which is what in this case? It's not quite the lowest common multiple, but you're right. You're on the right track. It's that idea. 3. So I can turn a 27 into a 3. So I'm going to do it like this. I'm going to leave the left side alone. And I'm going to do this to the x plus 2. 3 to the what gives me 27? 3. So this one's 3 cubed. And remember what we did when it was a power of a power? So I've got a power to a power. We multiply. And this is like 3 times x plus 2, the whole thing, right? Which is 3x plus 6. So I'm going to do that part first. 3 times x and 3 times 2. Now I've got both left and right sides rewritten with the same base. Therefore, their exponents must be equal. And in this case, I'm going to subtract 3x from both sides, and we're done. X is 6. What do you mean? Huh? That's what the question was. That's all. Okay, moving on. Next one. Write it down, put your pencil down and watch. I've got a left side, I've got a right side. What's the base on the left side? 4. What's the base on the right side? I know that's opposite for you because I'm going to... 8. Can I turn a 4 into an 8? Multiply by 2, but with exponents. No. Can I turn an 8 into a 4? No. 4 squared, 4 cubed, 4 to the 4. None of those are 8. What do I do? Huh? I can turn them both into a 2. What is 4 as a power of 2? Good. 2 to the 2, all to the 3x minus 1. You don't need brackets around that, but I'm doing it because it shows that we're like doing distributive property. What is 8 as an exponent of 2, as a power of 2? Madison, what do you think? 2 cubed. 2 to the 3, right. Check these on your calculator. Don't always just go with your gut unless you're really good at them, right? But there's no trick to getting that. It's by that part is like a guess and check. So I'd like, well, I'll try 2, try 3, try 4, try 5. Oh, I found it. And then move on if it's a harder one, right? We won't do any really big numbers. Okay, and then I multiply the exponents on both sides. So I get 2 times 3x minus 1 is 6x minus 2. 3 times x minus 4 is 2 to the 3x minus 12. Now I've got both sides written as powers of 2. See how this works? Is it starting to come together and make sense? I hope so. Therefore, 6x minus 2 equals 3x minus 12. I'm going to do this quickly because we've done a lot of solving these equations. So I'm going to move the 2 over and add it to both sides. And I'm going to subtract 3x from both sides. So I'm going to get 3x equals negative 10. Divide both sides by 3. X is negative 10 over 3. 2 more. Ooh. What's going on here? What do you notice about 16? Okay, so I got a base of 2 on my left here. What do I notice about 16? It's 1 over 16, but what is 16? Anybody? It's the same thing. I still have to rewrite with the same base.
2 to the exponent 4.
16 is 2 to the 4, but it's in a fraction. What do you remember about exponents and fractions? This is like 16 to the negative 1, right? Flip the base. Is that familiar? I hope so. Flip the base. And then I can rewrite, and you don't have to do both these steps, but some of you will like to. 16, Zach told us, is 2 to the 4. 4 times negative 1 is 2 to the negative 4. So you could go straight to that step. 1 over 16 is 2 to the negative 4. Then I go, therefore, x minus 7 equals negative 4. Add 7 to both sides, and x is 3. Okay, one more. How do I write 1 over 27 as a power of 3?
3 cubed.
It's 3 cubed, and because it's in the exponent, what do we need to add to that? Pearson, what do you think? A negative. So you can show the work if you want, or you could go straight to 3 to the negative 2x minus 1 equals 3 to the negative 3. But if you wanted to do this, it's totally fine. And it's a good idea, especially, for the first few, to maybe show the extra steps. Therefore, the exponents are equal. I'm going to add 1 to both sides and divide both sides by negative 2. Any questions? That was like one of every different type. So there's a bunch of different types there, but it's the same idea for all of them. That'll be fine. It won't be an issue. And we'll see a little bit more why when we do checks tomorrow. So here's your practice. Okay, I think it's already up in the classroom. Page 23, 1 to 6 odds. It says solve and check. No checks today. We're going to do checks tomorrow. So don't worry about the checks today. And when we get a negative answer and when we do a check, it'll all just work out. Yes? No. Any questions about the math revolving around this?